Okay. Hi, everybody. This is Mrs. Buchanan, and I am going to give notes on the metric system. First, we're going to talk about what the metric system is, why we use it, and what do we call it. So, it's called measuring SI units. SI stands for System International. It's the International System of Units. This actually came about from France. There's a French Revolution, but it actually came about from France. And it was a way to organize scientific data. So there are some SI base units. All other units are made up of these. And we'll talk about what a base unit is and what a derived unit. So a base unit for length is meters. So you're going to fill this in on your note page. And the abbreviation is M. The abbreviation for mass, the base unit is kilograms. And yes, we do use other units for mass, but the base unit is kilograms. And that is lowercase k, lowercase g. Temperature is Kelvin. And Kelvin is something you're not familiar with, but it measures the amount of kinetic energy, and that is K. Time is seconds, and the abbreviation is S. Amount of a substance is mole, and it's MOL. And the last two I'm not going to worry about because we're not going to use them in chemistry. So we're going to move on from there. So let's talk about the metric system and why we use it in science and why we use it in medicine. Well, it's a pretty easy system to use compared to our American system, because if I were to ask you in class what 1 mile is equal to, 1 mile is equal to 5,280 feet. Not everybody knows yet. So, and there's other things. Most of you know that 1 foot is equal to 12 inches. Okay? And so on and so forth. So that's the imperial system. What we're going to use in chemistry class is called the metric system. So a terabyte starts here. That's a 10 to the 12th. And a gigabyte is 10 to the 9. A mega is 10 to the 6. These are things that we use for computers. So if you want to know how we store information in your computers, we do it by a megabyte, a giga, or a terabyte. And actually most phones are getting to become gigabytes because they hold so much information. We have kilo, we have hecto, we have deca, and I'm going to erase that. That's DA. Okay. We have a base. A base can be a gram, a liter, or a meter. We have deci, centi, milli, milliliter, millimeter. We have micro, which is 10 to the 6. A micrometer or a microliter means it's something really small. And a nano is 10 to the negative 9. Pico is 10 to the negative 12. We won't use pico in level 2 chem, but we probably could look at micro and nano. So, meters, SI base unit for length. That is the base. Can express all length in meters or with prefixes. So 1 meter, that's a base. This is your base. So I'm going to show you how to do this. If this is my base, that would be a meter. That could also be a liter. It could be a gram. Okay? So if I have 1 meter and I want to go to a decimeter, I'm going to move my decimal. So if I have 1 meter, my decimal is understood to be behind the 1. So if I have 1 meter and I want to go to a decimeter, I'm going to move 1 place to the right. So it would be 10 decimeters. That's where this comes from. Again, if I start at the base and I have 1 meter and I will move 2 places over, that's 100 centimeters. Okay? If I have 1 meter and I want to go to a megameter, now I'm moving to the left. So that means I'm going to take my number 1 and I'm going to move 6 places to the left. So 1, oh, I'm going to erase that and fix that. No. So we're going to have 1, 2, 3, 4, 5, 6. So those little swoop marks are zeros that I'm going to put in there. So I'm going to add 5 zeros in front. That's how we, 1, 2, 3, 5 zeros in front. So let's practice doing this. So if I have 23.8 meters, I'm starting at the base. That's where meters is. And I want to go to a hecta. So I want to go from, I'm going to change my color. And I'm going to go from here to here. So I'm going to move 1, 2 places to the left. 1, 2. So that would become 0.238 hectometers. Okay. So next one, 39. Where is it understood that the decimal is on 39? It's understood to be behind the 9. So I'm going to go from the base to centi. So I'm going to move 2 places to the right. So if I have 39, my decimal's here, I'm going to go 1, 2. So I'll put a 0 there and a 0 there. So that becomes 3,900 centigrams. Let's try another one. A second. A second can be a base unit. I'm going to go from a second to a kilo. So that means I'm going to move my decimal. I'm going to move it 1. So 1, 2, 3 places to the left. So if you look here, my decimal's right here. So I'm going to go 1, 2, 3. So it's going to be 0.000 0.0000842. Essentially what I'm doing is I'm dividing by 1,000. A mole is also considered to be a base unit. So I'm going to go from 456 moles to a milli. So I'm going to go 1, 2, 3, moving it 3 places to the right. So a millimole is going to add 3 zeros to the end. So that's going to be 456,000 millimoles, or 4.56 times 10. We're using scientific notation to the 5th. So let's look at another one. K. K stands for kilo. A is an amp. Okay. And that's a microamp. So we use amps in electricity. So I'm going to put my decimal behind the K. Or actually, I'm going to put my decimal behind the 0 in front of the K, if I can get my pen right here. So I'm going to put it there. And I'm going to go from a kilo, starting here, and I'm going to move to a micro. So I'm going to go 1, 2, 3, 4, 5, 6. I'm not done yet because there's 3 places between milli and micro. So 6 plus 3 is 9. So I'm going to move my decimal 9 places to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's a lot of zeros. So we're basically multiplying it by 1 billion. 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's 2.3 times 10 to the 13th. Now, here I'm at a byte. So we've talked about computers at the beginning. So a byte would also be a base. So if I'm starting at a byte and I got to go to a giga, I'm going, I'm going 1, 2, 3. 3 plus 3 is 6. And 3 more is 9. So I move 9 spaces. So if my decimal's here, I'm moving 9 spaces to the left. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 128 billion gigabytes is 128 gigabytes. That's typically what the memory is on your Apple phone. Okay. So let's do a couple more of these. 48 CDs. A C is a centi. No, that's the base. That's a candela. So CD is a candela, and you're going to a hectocandela. So let's look at this here. So if I have 48 CD, my decimal's here, and I'm going to do to a hecta. So I'm going to go 1, 2, 3, 4. So I'm moving 4 places to the left. So if I'm moving 4 places to the left, it's going to be 0.0048. So let's look at 88 kilograms. So we're starting at a kilo. Okay. Kilograms measure mass, and we're going to a gram. So we're going to go 1, 2, 3, and that means we're going to move 3 places to the right. So 1, 2, 3, 880 grams. And then C, a millimole, that's a milli, and we're going to move to a deci. So this should be a DA. A deci is 2 over to the left. So it's going to go 1, 2. So it's going to be 7,500 decimals. And A is an amp. So now we're going to go from the base. So that could be an amp. And we're going to go from the base to a deci. So we're going to move her 1 place to the right. So that's going to be 570,000 deciamps. Next is going to be a decaant. So that's going to be, it's going to be a decaamp. Actually it's DAA. Kind of weird. So now we're going to start here at the base, and we're going to go 1 over to the left. So if I move it 1 over to the left, it'll be 5,700. A nanometer, that's a nano, and we're going to go to a meter. So if we're going to go from a nano to a meter, we're going to move 9 places. So 3, 6, 7, 8, 9. We're going to move 9 places over to the left. So 3, 6, 9. So it'd be 0.450 meters. Okay. So next, what you do is practice your homework. And when you're done practicing your homework, we'll have an objection check over this.